Next, our 11 o'clock session is inquiry-based learning strategies for your outdoor classroom. We have Carly Hintz and Kacey Tait from the Riveredge Nature Center here. Carly is the education director at Riveredge Nature Center and started there in 2015. She has been an environmental educator and natural resource scientist and a volunteer coordinator since 2010. She is a proud former Badger, studying communications and environmental studies from UW-Madison and received her master's from UW-Stevens Point. Kacey is the inquiry-based learning manager at Riveredge Nature Center, starting there in 2018, and has spent more than 10 years working at nature centers, zoos, and forest preserves around the Midwest. She also did research in Madagascar and Borneo, studying carnivores. Kacey graduated with a Bachelor of Science from UW-Stevens Point, studying wildlife ecology, and has her Master's of Science from Miami University with a focus on inquiry-based learning. We are very excited to have Carly and Kacey here. Please help me welcome them to our last day of our online My Place in Nature series. I will turn it over to you, Carly and Kacey.
Excellent. Thank you so much, Victoria. And I'm here to kick us off and then really hand off and support this presentation that is largely going to be led by Kacey. Inquiry-based learning, as you heard in her bio, is her bread and butter, and we're just so lucky to have her at Riveredge to share her talents to improve our field-based outdoor environmental education programs. So I'm gonna quick share my screen and get our presentation going. And while I'm doing that, all right, you guys give me a thumbs up if you are seeing my screen. Okay. I apologize, I am on a dinosaur computer, so it's on my end, it's taking a while, but I'm glad to see some thumbs that are working for you. Also, just quick front load that my voice is kind of on the fritz, so I'm gonna just power through this in extreme brevity. But before we get going, we wanted to just encourage some engagement in the chat. Just want to get a quick pulse on who's in the room. So if you wouldn't mind sharing, in particular, your school or organization, where you're coming from, and something fun like your mascot or your favorite animal. And we'll just watch for those in the chat. And while you're sharing a little bit of information about yourself, I am recognizing that some of you have probably been to Riveredge Nature Center, and some of you may not have. So I'm going to show you a handful of gorgeous pictures and just tell you a 2-minute overview of who we are so that you know where we're coming from. And hopefully you can come visit us sometime. So Riveredge Nature Center is it's about a 400-acre nature center that's located in Saukville, Wisconsin, which is about 30 miles north of Milwaukee. We are about 54 years old, and our nature center is made up of what we call the best of wild Wisconsin. Of course, it's not the best. There's lots of great, wonderful places in Wisconsin, but we're known for our restored prairies and also our 1.5 miles along the Milwaukee River, which is the northernmost part of the watershed. We just recently built a beautiful river outpost, which is where we really have boosted our watershed education efforts. And we've also created some technology to support that learning. We also recently built a brand new sugar bush house, which is where we house all of our wonderful maple sap, which we turn into sugar and invite the public along that journey, in particular in the month of March. And that sugar bush house is home to our nature-based 4K program, which is about 50 students that come to Riveredge every day as part of their school day. We also have a 4-acre permaculture farm that we use to grow crops that not only are used for our events at Riveredge, but we also sell at local farmers markets. And then we're best known perhaps for our education programs. So our summer camp, our homeschool adventures and school programs, our family festivals. This one is Frog Fest in particular, and our tree climbing and adventure programs. A couple more quick facts. Oh yeah, kayaking too. Couple quick facts. We started about 3 years ago, a nature-based charter school, public charter school called the Riveredge Outdoor Learning Elementary School. And really work very hard through that program and through all of our nature center programs to make nature accessible to all. So you see a picture of one of the Accessibility Wisconsin track chairs, an all-terrain wheelchair that some of our roles charter school students used most recently. And then lastly, a plug, if you are in the Milwaukee area at all, our next really big event for Riveredge is Sturgeon Fest. And that's a 15-year project where we raise juvenile lake sturgeon and then release them with about 1,000 people down at Lakeshore State Park. So that's coming up September 19th if you are in the area. And with that, I'm going to turn it over to Kacey, but definitely just wanted to invite you all to join us sometime at the Nature Center.
Right. Thanks, Carly, for that awesome intro. And I hope you guys get a chance to either learn more about Riveredge or, get a chance to participate in some of the cool events that we have going on. So my focus is going to be more on what is inquiry-based learning and what are some strategies that you can use to get them going in your program, in your camp, in some of the various ways. And so this is going to be a quick sort of introductory thing, and then just going into some of the nitty-gritty details on how to develop some strategies. So you might already be familiar, but what is inquiry-based learning? It is a teaching method that combines student curiosity, and in this case, the scientific method. Inquiry can be more, you can have inquiry-based learning in areas other than science. My focus for my presentation is more on the science aspect of it, and it hopes to develop critical thinking skills. So it's really a cyclical thing where, questions lead to an action plan, which leads to reflection, which hopefully leads to some more questions. So with the question, a lot of times it's based on observation, your own curiosity, your own background experiences or background knowledge, forming an action plan on how to answer it, analyzing that, and then thinking about what happened. Why did this happen? Is there a larger application that could be applied to this? And go ahead for the next one, Carly. Now, the thing is, a lot of people love talking about, inquiry-based, but there are different levels of inquiry, and some of them are much easier to implement in a program than others. A lot of times with the constraints of, public teaching schedules, with how long the kids are actually there at your center, usually you're stuck with more of a guided inquiry. But the goal is, if you have the time, if you have the resources available to you, open inquiry is a really, really powerful tool for getting kids interested. And so just breaking those down, guided inquiry, a lot of times the question is already provided, the methods are already provided, the design, and it's really about them sort of going through and collecting that data, and it's a lot more teacher directed. There's a lot more effort on the instructor's part. And it's a lot more focused on results, which is so good sometimes, but sometimes it's not always the point. And then as you go into more semi-guided, that provides more of a general theme. And then the kids or students, participants develop their own questions. They might develop a little bit of the methodology, maybe with guidance from the instructor. And there's given a lot of space and time for reflection. Open is the most difficult one to do, but it is really, really meaningful. It provides the time, space, resources, freedom, support. It's leaning more towards student direction. So it's more about what they want to do, They sort of come up with the methods. It's more about the process of building, of design, of science, and it hopefully leads to a lot more questions. And so we're going to sort of break those down with some examples. Carly, if you could. So here at Riveredge, we some examples of some guided inquiry that we do. Like I said, it's the easiest one to do. Sometimes we only have kids here for like 3 hours, and this is the easiest one. So some examples are like the Journey North Citizen Science Investigation or other citizen science projects. You know, we do like a wildlife murder or tracking mysteries. We do habitat comparisons between forest and prairie, and we do some water quality testing stuff. So the question and methods are already determined, but students add in their own observations, and they get a chance to interpret the findings to make discoveries. And then we have more semi-guided. So we have a river interactions program. So the theme is already there. You know, we're going to investigate water quality, but the students sort of get to choose their, you know, what they want to study with water quality, you know, whether or not they want to study dissolved oxygen, or if it's, you know, on the bank versus in the center of the river, if it's at, you know, different comparative to different times of water, different areas in the river, different times of day. Sometimes we're given a bit of guidance to them because they might not have as much background knowledge, but they're given a lot of time to go out and investigate and try different things. So it's a little bit more in the middle. And then for more of an open inquiry, Carly is going to explain a really cool project that she did with her homeschool students of a winter wildlife mapping project. And then one that I did, which was a camp related to zoology. So the different ways that we study animals. So in this case, the students developed their own questions. They developed their own methodology. And the guidance was given more from peers rather than from instructors, but instructors were given more supportive role. Given time to explore other related questions that stem from the initial one. So it's a really fun path to go down to see where it leads. And if you want to go. So, you know, we talked about some of the different styles of it, but I'm just curious to know, have you ever, with your organization or with your students, with your groups, have you ever led or have you ever been inspired by a different inquiry-based investigation that you wish to share? So you can leave those in the chat if you have ever been inspired by a really cool project, or maybe you've gotten to do one with a group. Just like to see. And maybe you don't even know if it is inquiry, but maybe you thought it was a really, really cool opportunity, a really interesting project. And I know sometimes it takes a while to type up too.
I was going to say, if you're brand new to inquiry too, we would appreciate that humility that you're willing to share. Yeah, that's a good point, Victoria. Living on a farm is a great daily experience in inquiry. I think I'll just keep going and seeing if maybe some of these examples prompt your own past experience or your own interest.
All right, so we're gonna keep moving on ahead, but feel free to keep adding in your comments or ideas.
Sorry.
So I'm going to sort of break down some strategies on how to develop an open inquiry, because like I said, it is one of the more difficult ones to implement, but with the right strategies and the right kind of methods, it is possible, and I have done it, and I've done it quite a bit. Just sort of breaking down how to do that. So some important things, developing a question that is student driven. So you want to really make it something that they're passionate about, they're interested in. That's going to be the ones that really something that they're personally interested in, you're going to be more motivated than if you're sort of assigned a topic. Make sure that you're giving them enough time. It really takes some time to really make a meaningful study. You want to give an opportunity to do multiple tests or even do a pilot test beforehand. And knowing that the results shouldn't be, it's great to get results, but that's not really the main goal of inquiry. It's more about the process of investigation, figuring things out for themselves, which is really, really difficult to watch sometimes, because that means failing sometimes. And that's a really important skill to learn. And some students are really challenged by it. I'm a personal perfectionist, and it can be really to be able to be like, okay, that didn't work, but how can we make this better? How can we develop this for next time? And it's resisting the urge to step in. I have heard so many students give me methods and I'm like, this is not gonna work. You're gonna find out, but I have to like sort of zip it and keep it under control. And I'll talk about this in another slide, but talking about having some guiding questions of what ifs can really, really help with that. It can be hard, especially if you're more of a formal educator who's used to sort of having that control over your class. And it's also setting up a foundation for qualities of good science. I think that's always important to know. What are the foundations of a good experiment? Being consistent, having things that are repeatable, measurable, etc. Go ahead to the next one, Carly. So this is sort of the steps that I went through with developing my open inquiry and sort of going through step by step what I did with my students. So first off, I had them create a wondering journal. So things to help inspire their own interest, what they are curious about. They write down their thoughts. And then there's also another urge in today's age of technology of wanting to look things up, and resist that urge as much as you can, because it's so much more meaningful when you can find it out for yourself. There's one thing to, just find the answer, but like maybe you can actually see it through a test, through your own eyes. And then if you have time, start sort of categorizing those wonderings, have them form maybe their favorite ones, maybe if they can see that there's some things that are the same versus some that are differences, factors that you might have that might be having an impact on what they see. So for example, this was an open an inquiry that I did when I was sort of training on this. I was at these pools and some tadpoles were rushing away from me, and some of them were just like not even afraid at all, and I could like just scoop them up. And so I was thinking, well, maybe this is by plants or no plants. Maybe this is by shallow versus deep water. Maybe these are the same species of tadpole versus other species of tadpole. So just thinking about how to break down this initial wondering question. And go ahead to the next one, Carly. And the most important thing of developing an open inquiry is constructing a good question. You don't want it, so here are some good, some good things to think about when constructing this good question. They should be answerable, obviously, giving constraints that you have, and also the available resources. Wow, it would be really fun to have a drone to go and monitor these animals, but we have to think about what we have. What are the time constraints that we have? If you're thinking about seasonal things, if you have them coming back throughout the year, you could do seasonal stuff. If you have these kids for a whole year, you could talk about winter versus summer, or different weather days. But if they're there for a week, there's going to be a lot more constraints. And you want to move that question away from why and how. So like, why is it the way it is, to what are the differences? Where are these things happening? What time or when are these things occurring? You want to be comparable. So you don't want it to be a one and done question, but you want to compare one, measure two. Those are the way that you're going to break it down to an easy question that should be hopefully be answerable. You want it to be interesting. Once again, you want it to be something that they are inspired by, that they are personally curious about. And you want to be simple and direct. So you don't want to complicate the question with a lot of jargon or fancy equipment. They should be able to do it with simple tools. So a good example of a comparative question, like I said, comparing one, measuring two. I want to know, I was seeing that my observation was that there's a lot of grasshoppers seemingly, in the prairie, but I want to know, like, I saw some grasshoppers in the forest. So maybe are there more grasshoppers in the forest or prairie habitat? Or maybe you could even do more of an edge habitat, so that you're only measuring grasshoppers, but then you're measuring their density in two different areas. A bad example might be, do the types of plants influence where grasshoppers live? That's going to take a lot more research, a lot more complexity. A complicated one might be, this is still doable, but it's going to make it more complicated, where are there more kinds of grasshoppers in forest or prairie habitat? Now you could certainly do that, but that all, now at this point, you're measuring the different types of grasshoppers. You're comparing two things, or maybe even more than two things, depending on how many species of grasshoppers there are. It's going to take a lot of background knowledge, or maybe some more technical skill that your students might not have. And then you're still measuring those two habitats. But it's definitely possible for older students, maybe in high school age. But at this age, I've done this with fourth grade and up, certainly you want to keep it as simple as possible. It can lead to more questions later on, but for now, just measuring the amount of grasshoppers that you have and thinking about some ways that you could set up an experiment with that. So I just want to give you a chance to, Carly, go ahead, to start developing a question. So these were just some things that I wondered, and I actually have developed studies on some of these from my own wondering journal. So these are just, and one of them was just kind of put in there the other day. I thought it was really funny. I was driving by a neighborhood, it's like whispering pines. I was like, why are they all called whispering pines? Are they really that noisy? So some of them are more on the silly end, but I want you to go ahead and take a moment to think about maybe one of these questions, or maybe a question that you've had in your mind, and think about how would you turn some of these why questions into a comparative question. So remember, you want to compare one, measure two. What are some things that you could measure out of these questions? And you could go multiple ways with some of these. Think about maybe some physical factors or elements you could measure. And if you think of one, go ahead and leave it in the chat. And I'm just going to give you like maybe 4 or 5 minutes or so to just sort of think about this. Looks like we're right on time here. But go ahead and start thinking about, okay, what question are you drawn into? And then how could you make a comparative question around this? These are looking really good. All right, guys, about maybe one more minute.
Yeah, and I just wanted to quickly, I see Susie's comment about kind of the challenges of incorporating semi-guided or open inquiry. And I'm not trying to punt that question, but we do have some space towards the end that we'd like to focus more on some of the barriers or challenges. So I'm gonna just flag that and hope that we can talk a little bit more about that later.
Thanks. All right, guys, so you did a really good job developing some comparative questions, and it's a really good practice to start. It can be so easy to make a wondering really, really complicated, but we want to be achievable with our questions. So, you know, obviously the methods might be more specific, but, you know, we like, even I saw someone wrote, you know, comparisons between cities, comparisons between different locations, different water, fragrant versus non-scented food. Food studies are great and really easy inquiry investigations to do. And yeah, even with the bee, you just as simple as red flowers versus yellow flowers, you know, you could do every color flower in the field and it's going to take a really long time. But just to limit, you know, shorten it down to some easy parameters, you can always expand from there. And that's going to make it a lot less overwhelming for kids to really get engaged. It's more about, you know, it's more about process and figuring out how to develop a study. All right. So yeah, I loved reading these. Let's go to the next one. And then the next step is obviously developing a prediction and an action plan. You know, thinking about what is their prediction and why. Thinking about what they will be measuring, what tools will they need? Are these tools actually attainable? How will they collect the data? And if they are forming groups or if they're doing it individually, what roles will they have within those groups? At this point, a lot of times with their predictions and even with their methodology, I like to have peer review opportunities because even though, like at this point, you know, your students are sometimes more perceptive than you might have thought, and they might catch on to some inconsistencies within their peers more quickly than you might imagine. So I give them an opportunity to really hone down on their question, talk about their question. Maybe I might have an initial peer review of just their question and give a chance for people to provide feedback, and then also have a chance for feedback with their prediction and methods after that point. So it's really taking a step back and taking it off of your shoulders, which, like I said, is a little bit scary as an instructor, but it is really great to see sometimes your students sort of step up and be like, you know, have some of this feedback. I like to use the slide as what does nice feedback sound like, you know, not like this is stupid, this isn't going to work. One thing you might want to think about is blank, or I wonder what would happen if that. And so really giving them that that opportunity to sort of hone in on what their thoughts might be. Resisting assumptions is really important when making a good prediction. And yeah, be helpful, be specific, be kind is also another really good one. All right, and then the next one. And you can think of some other ways to do it. Testing it out. I really, really think it's important to have the opportunity to do a pilot test, because that's when you really figure out like, oh, wow, this actually is not going to work. And sort of going back to the drawing board and reevaluating, and also giving another chance for peer review. Like, okay, so I tried this and like, this was not working at all. I think next time we're going to try this, and, you know, just sort of making it more of a conversation making it more of a collaboration between others. And then with the end, obviously summarizing your data, reporting and findings, giving a chart, a graph, brainstorming how to improve the experiment if they did it again. And if there's time to, go for it. Like, let's keep this ball rolling if they're interested in it. Thinking about what other questions arose from the experiment. Are there large implications? Could this be helpful to some way for conservation or research? And yeah, so I think the next slide is talking about some examples that we've done with, oh yeah. So here is some, so that is sort of my bare bones way that I've gone about this in the past. And we'll go into specific examples of some projects that we did with students. So, coming up with a wondering journal, making a really good comparative question, having opportunities for peer review, making a test that is testable, and having an opportunity for, reworking things, pilot tests, and really sharing and moving from there. But I know that some of you have challenges with this. So what do you think is the biggest challenge to implementing inquiry-based learning with your students? Yeah, having enough time is definitely a barrier for sure. And that's where, the guided versus open, it is it takes a lot less time when you already have the question, when you already have the methods, especially if you only have an hour with students, if it's a 1 hour science class. And I know one of you had mentioned standards as well. I think science standards specifically might be like a specific learning standard, but there are engineering standards or, that are more based on, developing a science project that I think can still be achieved. But if you're looking for, like, if you are a science teacher and you want to achieve this specific learning standard, LS1, et cetera, that can be difficult if they're going their own path. And they're more curious about this, but there are still, there are still learning standards assigned to more of the thought process. So more of, the engineering, building, designing sort of things. Yeah, it's difficult, especially for students. Once they get into like middle school and high school, it's for students and for teachers. A lot of the kids are used to being told kind of, they're uncertain of themselves. Sometimes they're afraid to fail because they don't want to get a bad grade. They're afraid to really, think in this way. It's a challenge for them, some students. But it is an important way to think. Yeah, to not have the answers right away can be challenging, which I think it benefits students to be able to be in groups initially. Because you will have some that really flourish in this style and some who will struggle. So sort of teaming them up is good early on. And then eventually as they get a little bit more comfortable, they can branch off. Yeah. Inquiry-based, the goal is to really put everyone more at a even playing field. You don't have to have all the answers, and that's okay. You're all sort of collaborating together, to solve a problem. All right, well, this is really great. I'm gonna keep moving on because we've got two really great examples to share with you of sort of inquiry-based open style things that we've done, both of us. So my example that I have for you is I developed a camp called Camp Zoology. I was fortunate enough to be able to lead this camp 4 times, two sessions for 2 different summers. And the focus of this camp was on learning how we study animals. So each day we focused on a different methodology, and it all built up into this last day where they got to design their own animal study. And so I guess there was a little bit of a parameter set, but they still got to develop their own questions for sure. And it was very open-ended with what type of question it was, whether it be a survey or et cetera. So for day 1, we introduced the wandering journals and sort of the general plan of what we were sort of leading up to. We learned the basics of the scientific method and how to set up an experiment. I because it was all crushed into 1 week, I thought it was very useful to do example studies. So each day we sort of did set up an experiment. I sort of showed them an example of a different experiment. So we had a hedgehog. I don't know if you know what anointing is. It's really adorable. It's where hedgehogs find something smelly that they really like, and then they smear it all over their back. And so we had the experiment of like, okay, so how do we, what smells do they like? Do they like certain smells more than others? How do we set this up so they can encounter all of these smells equally? Thinking about being consistent. And so we had them in this kiddie pool that was circular, and we spaced them out equally distant from one another and placed her right in the middle. And we did it a couple times to see if there were some differences. So that sort of like that made a foundation of like how to set up an experiment. And day 2, we continued with those wonder statements. We started to form categories out of them. We learned some basics of tools of measurement. Some things that we could use as tools, like how to estimate distances. Our study for that day was, do ducks feed more at the water's edge or the center of the pond? And so, learning how to estimate an eye distance is very difficult, but it's an important skill to have, especially if you're doing field science. Day 3 was kind of our really work day, where we had them write down their favorite questions on a board. We discussed and combined similar themes. So maybe a lot of them were really interested in bugs. We might be like, okay, we're gonna have a team bug for sure. And then we had them form teams around their areas of interest. Some of them chose to work individually because they were just very inspired. They started developing their comparative questions and their predictions, and we had a couple rounds of peer review. And then for that lesson for that day was, before we got into that, was learning about ethograms. So how do we monitor animal behavior, and how do we not make assumptions when monitoring animal behavior? Because it's very easy to place human emotions onto animals when it's not always quite clear. So we did ethograms on, our red squirrels or gray squirrels more active? And so they learned how to do ethograms there. Day 4, we finalized their plan of action. We did a pilot study. We met back to refine the plan and then did a little bit more peer review. And then day 5, they did their final study. So they broke out. We actually was thankful enough to have volunteers to go with each of these groups. So I pretty much just hung out at the classroom and waiting for their return. And they got to have 2 or 3 hours to sort of go out and do these studies. And if you're outside and if you have clear boundaries, it makes it a lot easier. Sometimes you might have to have everyone go together. We had moments where we didn't have enough volunteers, and we had to sort of combine 2 groups, like we were going to do them yours, and then we're going to do yours. And then we gave them some time afterward to make posters and present. So I don't have very many photos from these experiences, but I did have a couple that I just shared from Camp Zoology. So they really, really enjoyed these, we called them quests, and got to do some comparisons. And it was a really fun experience. And then Carly, you did some really cool things with your homeschool group. Do you want to talk a little bit more about that?
Yeah. And I'm hoping that you guys can hear me okay. There's somebody doing some sanding, I think, near me. So there's some interesting background. My example is actually a little bit more haphazard. So we entered our unit of inquiry for our homeschool Edventures program with primarily middle school age students. And this kind of speaks to Susie's question earlier about like teaching to standards and trying to make sure that you're ensuring, you know, the right content so that you're guiding learning, but also remaining flexible and open to the inquiry process. So we went into this knowing that our standard was going to be mapping, that we needed to teach the skill of mapping to our students. But you know, as you'll see, things unfolded. We taught mapping, but things unfolded and we allowed them the opportunity to unfold in like a much different way. So our setup was really like day one, just intro to mapping, the understanding the key elements of a map and looking at kind of the different layers that we might see as we traveled to a class study site on our Riveredge property. Then the magic happened when we actually got to the site. So this is where, you know, without knowing the term wonder journal until recently, this is where we really had wonder journals. And we did just some basic like sit spot work almost to just let the students individually get to know the site. And our driving question as a whole class was just what can we learn from this area as it changes over winter? So again, kind of an example of a process that started out semi-guided or guided, and as you'll see, kind of got a little bit more open. So what we found when we got to our site was one of the students found a deer leg bone, which I'll show you in a moment. And this leg bone just made the students go like gaga over their storytelling of like what happened here. And, you know, again, then giving them the freedom to explore and find the tracks that were fresh near the area really got everybody thinking about questions around this carcass, right? And they wanted to know, like, how did this happen? How did the deer die? What animals visit this leg bone? Who's eaten it? Just the list goes on and on of the questions that they then, you know, spurred from this area. So instead of focusing solely on mapping, we really expanded, kind of having an awareness of the resources and tools available to us was incredibly helpful, because I knew that from their interest, we might have keys to some of these other tools that could help guide their individual questions. So we incorporated a trail camera into the mix. We also used a GPS, and we formed small groups. And one group of students, for example, started looking at, I'll go back to this slide. They started looking at how our animals we found at our study site adapted to survive. So some of them really wanted to know about the specific winter adaptations and like, did this deer die because it was winter, or was it killed? You know, they just wanted to know more about animal adaptations. Where are they going? So where are the animals that visit this carcass going? So that's where the mapping component came in. And so some of the students then mapped what we called rendezvous points, or areas where humans travel and wildlife travel, and where they intersect, but not necessarily at the same place and time. Those are just a couple that came to mind. And then really this last piece, I'm giving an example of, oh gosh, how could I forget this? So we ended up learning that there were somewhere around 8 different species of animals that visited this deer leg bone through our trail camera footage. And we were so blown away. A raccoon, a coyote, a fox, another deer, a fellow deer. All these animals started to frequent this area. And then the students, this is where we kind of stemmed from scientific inquiry and really kind of incorporated more creative thinking and imaginative thinking. And I just let them roll with it to do some storytelling about, based on what we learned, what do you think happened here, and how can you address your question in a more of a narrative form? And although you probably can't read this example, you do see the striped, what was this called? One student that went just a total silly route and said that once she arrived, she met a dwarf tiger kitten who had strayed from a local farm. So like the two became best friends. They told jokes. Anyways, just goofiness definitely ensued. And so I think it's okay. It's okay sometimes, right? Like, did we learn about mapping? Yes. Did we incorporate some new skills and some new tools? Yes. Did we have fun and be creative and be silly? Yes. Along these lines, if I heard one of the comments in the chat is the struggle with teamwork sometimes and group questioning. We had a parallel investigation that we just called our home naturalist niches. And so we allowed students to really guide their own individual questioning and individual inquiry at home. And then they presented. So they came up with their own questions in parallel to this class project, and then presented on those as well. So that's a photo of the student presenting his findings from his home naturalist niche. Cool. So Kacey, I'm going to turn it back to you.
Oh, sorry, my computer is almost dead, so I have to run and get this. So real quick, some great tools for.
Oops, Kacey, I think I accidentally muted you.
There we go.
I'm muting myself.
Can you hear me again?
Yeah, back up.
So just really quick, wanted to talk about some tools you can use for organizing your study. Obviously, you don't want to bust your budget with doing scientific studies or things like that, but just some really useful things. One that I used for ethograms. Ethograms are really, really good for more captive animals. So if you have a class pet, if you have animals that aren't capable of flying away, these are really, really great. So this app is called Observe to Learn. It's made by the Lincoln Park Zoo. It's designed for zoo animals, but I've used it with wild animals that are just like moving around outside, as long as you don't lose sight of them. But basically it really, really trains kids how to use ethograms. They put in, what time they're doing it, some basics on the species. It tells you when to tap every 30 seconds or so, and then it creates a chart at the end that breaks down their activity. So whether they're being more social, more rested, if they're eating, you can break down these categories. So it's really, really great app if they're interested in doing behavioral stuff. Know what you know, what you want to know, what you've learned charts are also really great. I'm sure a lot of you are familiar with those, but it's a great way of organizing sort of thoughts on what they're curious about. Live cams are really great for students that are interested in animals that are hard to see or rare. You can do entire observational stuff with, there's so many live cams out there of birds nesting, of trout migration. There's one for like, underwater cams. There's a lot to choose from. The 5-in-1 test strips are great. Obviously, they're not the most accurate for water quality testing, but they do give some good parameters on just basic parameters on water quality, and they're pretty inexpensive. You get them from your pet store. A bird feeder you can do so many investigations just from a bird feeder and comparisons between species, between times of day, between seasons. iNaturalist and Seek, I'm sure you guys have been talking about a lot. they're always great for using map data, so comparing locations of species or animals or plants. And if you have more to spend, obviously, you can get some more collection tools, but know that, if you're creative and you think outside of the box, you can use a lot of things from your kitchen to do a lot of those. So yeah, and even the phones now are great recording devices for playing things. I had kids do a study on how do birds react to different sounds, and so they were playing. We got like a little Bluetooth speaker and to borrow from the day, and they were playing different sounds to these birds to see how they would react. All right, go ahead real quick. I think we just got just some quick tools that are available through Riveredge if you're ever interested. We do have water quality kits. We have a fantastic program called Testing the Waters, which lends out water quality testing equipment, like actual nice quality grade testing equipment to teachers around the area. And allows the students to keep track of their observations and do comparisons. We have a forestry education kit. We have a ton of animal specimens, so you can look at birds or bones. We've got a lot of skulls and cool furs. We have a YouTube channel which you can learn more about the natural world through. We also have a maple sugaring app that's free to download. You have to reach out to us for it, and a water quality biotic index app, which helps keep track of also water quality as well. I will, if you're interested, you're more than welcome to reach out to us. I just want to leave enough time for questions. So if you could go to the next one. I think that next slide is the question slide. So we, if you have anything else you want to reach out to us about, resources, questions, ideas, we are happy to help you develop something. Here's my email, here's Carly's email, and then I just wanted to open it up for the last few minutes to see if you guys still have any remaining questions.
Kacey and Carly, thank you so much. There was so much great information in these slides. And just to let everybody know, this recording and this presentation will go into the workshop session online in our closed community. If you want to revisit some of the things that were, some of the ideas that were a part of this presentation.
Are there simple tools that you feel are key to providing to students for inquiry? I don't think there are. I mean, for a specific question, yes, but for inquiry in general, I don't always think their tools are necessary. It just really depends on what type of question they have. I think the wondering journal is probably the most important. Being able to have a spot where they can really guide their questions and develop questions, Yeah, I can't think of something specific. Obviously, when they break it down more, they can. Yeah, garden stores also have really good comparative kits for soil. So that's good for like habitat comparisons if you're looking at soil quality. There are a lot of expensive tools out there, but there's there's also a lot of inexpensive ones. They're not as accurate, but it's a good foundation. It's a good starting point. These kids are not going into research grade papers here. So just getting some foundational, stuff back.
Yeah, and I'll just plug, since I know not everyone is from Wisconsin necessarily, or from Southeast Wisconsin in particular, I'll just plug the role of nature centers and informal science centers as just wonderful resources to guide some of your students who have specific interest in nature and the natural world. And thank you so much just to Field Adventures for inviting us. It's like such a unique space to have have formal and informal educators all together. So I really appreciate you doing this and inviting us.